Welcome back, guys. Now let's just take a look at this question. They say a school investigated a number of learners who arrive at school on time, arrive late, or who were upset during the particular week. The results are recorded in the following table. There were 100 learners in total, So this is another question, guys, about the contingents. On our previous video, we've done this kind of stuff, and I promise you I'm going to do another video so that you can be able to understand this on more details. So on this one, on our previous video, we say that the total number of the characteristics that are here, you will find it where you will find it here, So this is the total number of the boys, which is 65. The total number of the girls is 35, And the total number of the people that arrive on time is 65. The total number of people that arrive late is 25. The people that are upset is 10. And I also told you that this number that is here is called what? It's called the total number of what? Of sample space, of total number of the sample space, perfect. So now let's just take a look at the questions. They say, calculate the probabilities of a learner arriving late at school. So now we're going to take a look at the learner that arrived late. So in other ways, they need the probability of a learner that arrived late, So for the one that arrived late, we're going to just take a look at the total because they didn't specify. So we're going to look for the total number of the people that are late. So for the late is how many? Is 25. I told you the line that is here, it shows us the total. So the total people that are late is 25, which is 25 divided by what? We are going to divide by the total number of sample space. How many? Which is 100 here. Is going to be 100. Now let's take a look at the second question, which is B. So for the B, they say a learner that arrive on time. They want the probability of the learner that arrive on time. So this was the probability of on time, actually, So it's going to be what? So how many people that are on time? How many in total is going to be 65. So this is very easy. 65 out of what? Of the total number, which is 100 there, which is 100. So then the second one, they say a learner being absent if the learner is a boy. I want you to pay close attention to this one, guys, because it's going to be very, very confusing. And I talked about it on my previous video. So they want a learner who's absent, who's being absent, and that kind of a learner is a boy, So a lot of mistake that I saw in a lot of students when they talk about this kind of stuff, when you want the people that are upset, you will go and take the total, But here they specify they want the people that are absent, that are absent, and it's also a boy, So I'm not going to take the total. I'm going to go for the line of boys and absent. How many of boys that are absent is 7 of them. So the probability of absent, which is boy, or a boy, I would say, and a boy is going. Don't mind the way I write this. I just want to illustrate to you guys. Yeah, they were not going to give you mask for doing this kind of. So this is for C, actually, So which is going to be what? It's going to be 7 of them. It's going to be 7 divided by what? So on this one, I want you to pay attention. Whenever they specify, or they need a boy, whenever they specify, we're not going to use this number as a total number of sample space. Why? It's because the number that is here, it covers the people that are girls and boys, and here we're wanting specifically boys only. Does that make sense to you? So the total number of sample space is no longer going to be 100. It's going to be what? The total number of all the boys, So what are the total number of all the boys is 65. So going to divide by 65. So this will be a probability of a boy being absent, and if that kind of a person is a boy, a learner who is being absent, and if that learner is a boy. Does that make sense to you? Perfect. So going to letter D, which they need a probability of a learner arriving on time, and if that kind of a learner is a girl, on this one, we're going to just take a look at the girl that is on time. How many of them is 25, It's not 65. 65, guys, it covers the boys and the girls that are on time. But yet they specify they want the girls that are on time. How many is 25? So this one is the probability of on time. So it's going to be 25 divide by what? We're going to divide by total number of sample space. So the sample space is no longer going to be 100 because this 100, it covers the boys and girls. So, but we're going to divide by the total number of all the girls that are there, which is 35. Does that make sense to you? Perfect. So it's going to divide by 35, so this is the probability of a learner that is arriving on time, and that kind of a learner is a girl, So going to letter E, they say, calculate the probability of a learner arriving on time or being absent. On this one, guys, I want you to take your book or your notebook and listen to me very carefully, because it's going to be a little bit spectacular, but it's very, very easy. And I just want you to understand. So they want a learner that is arriving on time or being absent. So in other ways, this one, we can write it this way. A probability of someone who is late or absent, Perfect. So what I want you to remember is that when we talk about or on this kind of contingency table and on a tree diagram, why do? We add always, because these are the independent events. That's why it's getting a little bit confusing. When we talk about or, it's not the same when we are using that kind of a formula whereby we will say the probability of A, and no. On this one, we are going to add when there is or. So in other words, here, they're looking for the probability of late people plus the probability of what? Of the absent people. Does that make sense to you? Perfect. So the probability of late people, we're going to say what? How many people that are late, to the total number of those kinds of people that are late here. So the total number that are people that are late is what? Is 25. They didn't specify that they need a girl or boy. They just say the people that are late, which means we have to count the total, which is the total of the people that are late is 25. So just going to say 25 divided by what? So once they didn't specify, it means that our total number of sample space is going to be this one, because this 25, it includes what? Boys and girls. So just so that this is going to be our total number of sample space, which is 100. Does that make sense? So then we're going to plus with what? The people that are absent. How many that are absent? Which is 10. 10 divided by what? How many? Total number of sample space is 100, which is 100 here. So this one is going to give you 35 out of 100 actually. So this is the probability of the people of a learner arriving late or being absent. So when we talk about or, since this kind of type of contingency table and tree diagram is an independent event, we add. I want you to also note that kind of stuff. So going to the last question. They say they want to calculate the probability of a learner arriving late or being absent if a learner is a boy. So this kind of a question is the same as this one, but this one, they just added this kind of a condition that those kinds of people that are late now and those kinds of people that are absent are what? Are now a boy, So in other words, here they just want the probability of a boy who is late, boys actually, who is late or absent, Perfect. So when they say or, what do? We add. I want you to also understand. So in other words, they're looking for the probability of a boy who is late or plus the probability of a boy absent. I'm writing it in so that you can be able to understand. When they talk about or, we do what? We add. So going to the look for the probability of a boy who is late. How many of them? Boys who is late, which is late, is 18. You see? These are the 18 boys that are late. This is going to be 18. So the confusing part comes here. We're not going to divide by 100 here. We're going to divide by what? The total number of boys that are there, because this 100, it includes girls. Does that make sense to you? So we're going to divide with this 65 because this is the total number of what? Of boys that are there. So we're going to divide by 65 plus the probability of a boy who is absent. So for absent is 7, which is 7 out of what? Of 65 boys that are there. 65. Does that make sense to you? Perfect. So from here on, 18 plus 7 is going to give you 25, which is divided by 65. So this is the probability of a boy this is the probability of a learner arriving late or being absent if a learner is a boy. So that's it for this kind of a question, guys. See you on my next video. Sharp.